All right, in this video, we are going to introduce sequences, which are basically just number patterns. But we have specific ways that we can show and represent them. And in the next video, we're going to learn how to write rules for them too. So let's start with two examples. I want you to copy these down with me, and I want you to try and fill in the next few terms after I do the first ones. So first, we're going to do sequence A, and that's going to be 5, 8, 11, 14. Notice I'm separating these by commas. I want you to fill in what are the next three terms, please. And then we'll also do sequence B. We're going to use these two sequences throughout this video. Sequence B is 3, 6, 12, 24. I want you to fill in the next three terms. Take a minute, take a look at these, figure out how they're growing, and fill them in, please. So a sequence, let's define a sequence. And we'll talk about the answers here. A sequence, I'm going to call it a list of numbers that progresses. They don't always get bigger, right? They can get smaller. So I'm going to say progresses in a predictable way. Doesn't mean they're always easy to predict, but there is some sort of a pattern. It's not always possible to write rules for them, but there should be some sort of a pattern there. All right. So for sequence A, hopefully you saw that it's growing by adding 3 each time, which would mean that after 14, we would have 17. After 17, we would have 20. And after 20, we would have 23. Because it was doing plus 3, plus 3, plus 3. That's called the common difference, is 3. Then on B, hopefully you notice that this one is doubling. This one's going times 2, times 2, times 2. So that would give us 48. And then 96. And then 192. Yes, fantastic. Okay, so when we are talking about a sequence, we always talk about two things. We talk about the first term. So what is the first term? And we have a lot of stuff with sequences is about the notation. So if we're calling this sequence A, then we could say that A sub 1 would be the first term. So A sub 1 is 5. What is A sub 4? That would be like the fourth term. 1, 2, 3, 4. So A sub 4 would be 14. All right, that's A1. This is A4. Now you can also write these in function notation. So you could also say A of 1 is 5 and A of 4 is 14. It's just two different ways to write it, just like how we can use function notation, or like we can use f of x or y. They're kind of interchangeable. All right. And then what about for sequence B? So that would mean B sub 1, the first term of B would be 3. And what about the 6th term, B sub 6, would be 96. Does that make sense how we can kind of identify these? All right. So the first term, or identifying individual terms, is important. And the other thing that we do is we say, how is it growing? So sequence A is growing by adding 3. And there is a math way to like say that. We're going to save that for the next video because it gets a little bit confusing. And B is multiplying by 2. And the way that we're going to think about this is that you multiply the previous term. So the previous term times 2 equals the next term. And that's essentially what we're going to do when we write our rules in the next video. All right, so we can talk about multiple representations of sequences just like how we do for other types of functions. So we have the sequence, that's literally the list of numbers. We have a table. I'm going to show you how to do that next. You can turn that into a graph, and then we can make rules for them, which will be next. All right, so let's make a table for sequence A. So in our table, we're going to include all the numbers in the sequence, and we're going to include which term number they are. So we're going to call the term number n. So n is going to equal the term number. So n is going to be there. And then I can either say a of n, like that, or I could say a sub n, with like a tiny little n. They are exactly the same way of showing this. I'm going to stick with function notation because we've used that a lot. So unlike with a rule, we don't normally start with 0 because there is no 0th term to a sequence unless you are trying to like work backwards. Sequences always start with the first term. So that's an important thing to note. Sequences start with term 1, not term 0. So term 1 was 5. Term 2 was 8. Term 3 was 11. Term 4 was 14. Okay, and then we could continue like this as long as we wanted. You could even challenge yourself to try and find, for the nth term, how could we predict, given any term number? Think about, what can I do to 3 to get 11? What can I do to 4 to get 14? I could say that would be times 3, that would be 12, plus 2, times 3, that would be 9, plus 2 is 11, times 3 would be 6, plus 2 is 8. So that would be one way to write a rule for this. Go ahead and try and write a table for sequence B. All right, does your table look like this? When the first term is 3, the second term is 6, the third term is 12, the fourth term is 24. Now, these are two different types of sequences. So this one grows by adding, and the rule when we write it is a line. This is a type of arithmetic sequence. It's spelled, that word is spelled exactly the same as arithmetic, but for some reason it is pronounced arithmetic. This has to do with like grammar and the fact that it's an adjective rather, it has to do with what part of speech it is. I looked it up once because students wanted to know and I can't really remember, but it's pronounced arithmetic. Okay, so it's an arithmetic sequence, which means that it grows by adding. This is very important, make sure you write this down. Grows by adding, and the rule is a line. Okay, those things should make sense that those go together, right? Growing through, or adding or subtracting, I should say, because they could be getting smaller too. And the rule is going to be linear. Table B is not. Table B is geometric. Geometric. That one looks and sounds the way we want it to. And these geometric rules grow by multiplication or division, and the rule is exponential. Now, we haven't really done anything with exponential functions this year, so I'm not going to focus on how we write rules for these. We just know that they're going to end up being kind of in that general form, y equals a times b to the power of x, or in this case, you'd use n and b of n. Okay, now let's go ahead and do the graph. So we're going to do both graphs on the same one. We can color code them, something like that. And so when we graph it, as you might expect by looking at our table, the x values are going to be our term numbers. Term number. And the y values are going to be the values from the sequence. And even though it's a little bit confusing, like the term number is which number term it is, and then we would say it's the term is what the actual value in the sequence is. So I'm going to say the term. Okay, so first I'm going to do table A. I'm going to make table A be orange. So my first point is 1, 5, then 2, 8. I'm just graphing this like normal. 3, 11, 4, 14, and I can continue a few more since I have space. And now, should I connect these points? Probably not, because this is a sequence. And in fact, certainly not. This is a sequence. Like I have to add 3 to get the next number. I don't get to like add incremental values in between. This is the main thing that makes this different from just the equation of a line, right? Is that it's only these discrete values. So they do not get to be connected. I will make each dot orange to emphasize that they are not connected. So our big takeaway right here is sequences, all sequences are discrete, meaning don't connect the points, because the in-between values don't make sense, because there's no 1.5th term, right? There's no half term for me to get. It's like it's just term 1, 2, 3, 4, 5. It's not term 1.5. All right, and then I'm going to do the same thing for the geometric. So they kind of overlap a little bit, but not too bad. I'm going to make those ones green, and same thing. I'm not going to connect them. This is a sequence. They are discrete values. And that one has a curve, which makes sense because this is exponential, right? This is showing exponential growth. All right, practice problem. I've given you a new sequence. This is sequence S because it's a sequence. I want to know what type of sequence is this. So arithmetic or geometric. And so you'll need to remember how to write those words so you can type it in properly. And then I also want you to tell me the value of the 6th term. So what is the 6th term in this sequence? And is this sequence arithmetic or geometric? Good luck.